All right, here we go. We're going to start getting into the meat and nitty-gritty stuff when it comes to two-dimensional motion here. This is where we're going to introduce something you're not very familiar with, like Pythagorean theorem. Never heard of that. Stroke and toe we'll start talking about today. You should be familiar with that too. Okay? So, what happens if we now do not go directly on the x or y axis? We have a problem. Okay? Because we're now in two-dimensional motion where we have an angle. Okay? Now we know this is a 45-degree angle, but there will be situations where you will not know an angle. We're going to talk about how do we figure that out. How do we know the angle? Okay? It's not as bad as you think. It gets bad when you start adding multiple vectors. We're not doing that yet. Okay? So, here's one thing that's really important. You can shift an XY axis. What I mean is I could technically take this XY axis and rotate it so that the X is right on this. I mean, yes, it would make finding the magnitude easier because you'd be treating it like a one-dimensional problem. However, you would have to shift it back to get the actual direction. And so instead what we do is we're going to set a fixed location and we're going to use geometric things like Pythagorean theorem and SOHCAHTOA to help us figure out direction. Okay? And today isn't super bad, but it is, foundational, so I want to make sure we get through it all. And this here is talking about what we talked about last chapter, how your positive y-axis is directionally north, and your negative y-axis is directionally south. So if you hear south, it's negative. If you hear north, it's positive. Make sense? Okay. All right. You guys are probably pretty familiar with the Pythagorean theorem. I would agree. In your book, it just shows like a pyramid and how you get the hypotenuse side. And you guys are pretty good at Pythagorean theorem. If anyone need a refresher on, it's just a right angle. Okay? So if you know your x, essentially what this ends up being here is this. Okay? This would be your x component, this would be your y component, this would be your resulting vector or your hypotenuse. Okay? We could use geometry to figure out what that angle is. Okay? Later on in this chapter we'll be given a hypotenuse side and we'll be asked to figure out what the x and y components are. Or we'll be given an x and y component and be asked to figure out what the resultant vector would be. Or the hypotenuse side. Okay? It's not going to be overly difficult yet, but we got to lay a solid foundation here. Do I have the Pythagorean theorem on your notes? I mean, you guys know it, right?
Yeah.
Okay.
You put it on
C squared
plus B squared.
What's it supposed to be?
A squared plus B squared equals C
It's the
squared.
same thing.
But it's backwards.
Oh, well, I like to do things left to right, not right to left.
But then it's the cat.
Yeah.
That's okay. I don't know, like, I don't like having, maybe this is a personal preference, I don't like having my isolated variable on the right. I like to have my isolated variable on the left because I read left to right.
Never put that spot to it.
Do you remember that time where I had it and it was going to end up being the isolated variable on the right and I just flipped it and you guys all freaked out?
Yeah.
Would you want the stuff that you're working with on the left then if you read left to right?
What if you're Arabic and you read right to left?
Let's keep going.
Yeah, let's keep swimming. All right. Anything else to share about this? I'm more useful to go through the problem, so. All right, direction. Here's how we do it. Tangent function. Let's review SOHCAHTOA.
So There's opposite over
Side
adjacent.
over hypotenuse.
Opposite.
I never actually sounded out.
Ah,
Adjacent over hypotenuse.
Oh,
Opposite.
diagonal.
All right, so sine.
Sine. Opposite.
That's not gonna work, is it?
Sin.
Can you do it like this?
So sine.
Opposite over hypotenuse.
Yeah, I need more space.
Sine
Sine of theta
cosine
is opposite
over
over hypotenuse.
adjacent over
Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Review?
Yes.
We're good with this, I feel like? Okay, so here's how we're gonna go about figuring out the angle. Okay? If I wanna find this angle, a lot of times I will have an x and a y component that I can put in as the opposite and adjacent and find the angle here. So I could take this and isolate the angle, which means I have to undo tangent. How do we do that? Anyone know?
negative worse tangent.
Inverse tangent. So theta would be tangent to the -1 of your opposite over adjacent.
This is really gross.
And so if we know in the context of this problem here, our opposite would be our y number, and our adjacent would be our x number, and we would just plug it in, take the inverse of tangent of it, and you would have your degree angle. Oh, you needed to, your calculus, this is important. Your calculators need to be in degrees in this class. If you're in, pre-calc or calc, it has to be in radians. So, yeah, you need to be able to not forget to go back and forth, because it will mess up either my class or your
You
class.
need radians in this one? or
No, degrees. It needs
That's
to be
already one of
degrees.
those.
Which, I don't know, maybe you haven't gotten in calculus or pre-calc, haven't gotten to like needing to use radians yet or not. Okay? Alright, let's do some problems. We got 3 problems, so I think we're good on time. We're a little less than 20 minutes, so we should be able to get through all 3 of these. And this is where I really want to spend really the majority of the time.
I'll leave that up.
Okay? Context here. Bring the problem. You guys figuring out your calculators, or you're playing like Tetris on it?
Figured out how to draw
I
earlier.
drew a doggy.
The pre-calc.
I'm worried about letting you guys use calculators on these calculators on the test.
Oh yeah, there's so much
Advanced
stuff on
count
there.
is gonna be.
Dude, I
If we would've known all the conversions, like,
And
or
so
science,
yeah.
like it had unit conversions and everything, and sig figs. Oh, glad we didn't even know about it.
But
So it's
like, it has like electromagnetic, so like on the book where we couldn't.
Oh, it had no gas.
Alright, you guys are gonna have to tell me, because that's bad.
I like
Is it
gas.
just these calculators?
Yeah.
Yeah.
So I can't let you guys use these on advanced
Kramer,
camp?
no.
Oh, sure.
We made
Not until after I graduated.
So I could use it with this class. Wait, why? What can
What
you
you
do
want,
on that?
Lauren?
A lot of really evil things.
Yeah, you can program a lot of
That
stuff.
would actually suck.
No, but it's not programmed, it comes with it.
Well, you can also
You
program
can, but then you
a lot.
can't use it, you can't use it.
Program a whole bunch of stuff in there and.
The only thing airfield
for one.
Dude, look it up on the
But I've
internet,
never
you can
once
program, for the
used
ACT,
that.
there's so many cheat things you can download.
Yeah, that's just.
Okay, first of all, is that,
You can't use
first of all, is that ethical?
No.
What?
Alright, let's do this. Alright, I'm just gonna hold you guys to being good students that have the Holy Spirit inside of you that can convict you. Okay? Please. I know it's hard. I know we think we all have to have the best grade, but it's not worth it over having a divided relationship between you and your Heavenly Father. So, it's not worth it. Trust me. I experienced that a lot this summer, and it's not enjoyable. Alright, here we go. Got some archaeologists. The Great Pyramid of Giza. The pyramid's height is 136 meters, and its width is 2.30 times 10 to the second meters. What is the magnitude and direction of the displacement if the archaeologist climbs from the bottom to the top? So let's do a 2-dimensional pyramid here.
That's very illegal for him to climb up, by the way.
Okay? What is the height?
136, and it's not the thing that's across, it's from bottom to top. I learned that.
And what is the width?
2.3 times 10.
Is the width
Half of that.
It would help you a lot.
Well, no.
okay, so the total would be 2.30 times 10 to the second meters would be the full width. However, we don't need the full width, do we?
No, you gotta divide by
Why don't we need the full width?
Come to one
two.
side.
Well, look at where my triangle is, right? If I'm going to use Pythagorean theorem, which is what I'm going to have to use here, to figure out this displacement, because, right, last time I checked, the archaeologist isn't climbing in an elevator right here and just going to the top, right? The archaeologist is probably just walking up the side. Does that make sense?
Is that supposed to be equal,
What?
like your triangle?
Yeah.
So then you can divide by 2.
Yep.
Oh, okay.
Yep. So I want to know the x here. The x component, or your adjacent component, which should be half of that.
115.
So now I've got my right angle here. If I've got, this is my x, and I'll, oh, that's awful.
It's okay.
Okay, so you see the little triangle there. How would you go about then finding this distance or displacement, I guess?
Would you draw the...
Pythagorean.
Oh,
Pythagorean theorem.
Oh,
So your little lady here.
which one are you trying to find? How do you know it's on the?
You're finding the length of the hypotenuse.
Oh, you're not finding an angle?
No.
Not, yeah, does it ask us for an angle?
Oh, so you just showed us the angle thing in case we.
Well, we will find the angle for this, just to do it. Yeah, I do want to find an angle because I do want to talk about one of the things that's a little bit of a learning curve is figuring out how to word angles.
I mean, it's kind of close.
Basically.
It's 173.
178.1.
178 to 60.
I like it with us. Oh, crusty bun, yeah, it is.
178 meters?
I missed it.
Yeah.
Does that make sense if you do the Pythagorean theorem? I'm assuming you guys can do that.
Yes.
Is that a safe assumption?
They say
Yes.
yes.
Okay. Now,
And then direction.
it doesn't specifically ask us for direction. Oh, it does.
Yeah, it does.
It does. So let's find the direction.
Northeast.
Okay, and just saying northeast isn't going to work. You need to find a precise angle.
It's 45.
Is it?
It's
Wait.
likely,
No, it's not.
but I don't know because you don't
Okay,
have
so here we go. Inverse tangent, the angle.
Oh, that's why we're doing
And our opposite is what in this context?
Opposite was 136.
136 would be your y here, your opposite.
Probably for the bottom left angle.
Yeah, bottom left.
this.
Yeah, well, here's your right angle.
Yes,
We're
not
finding
That's
the
your
angle
angle.
that you want.
That's your angle you're looking for.
Okay.
Over 115.
Over 115.
So it's 49.7.
49.8
49.8.
49 point what?
49.8 degrees.
Celsius.
All right. Now, here's how you would write this. This is important. Okay. Where's our like x y axis here?
The height.
So this would be like x, y. Okay? So I would say 178 meters at 49.8 degrees what? Here's the difficult thing. We can't just say southeast. Here's how I say it. So it's this angle. I'm going to say the angle is going to be 49.8 degrees north of east.
That's so dumb.
Wait, what?
North of.
Why
North
are
of
you saying
east. Let me explain. Because this would be east, right? And this is north of it to get my angle.
And of that.
Now, there is one other way to say it. You could say east of north, but it's not the same angle. If you say east of north, you're starting with north and you're going east, which would be the remainder of that angle, which would be 90 minus this. Does that make sense? So you can say east of north or north of east, but it's not the same angle.
North of 0.
Okay, so here we go. I'm gonna separate it here and say we got something like this, and this is our angle, right? We said this was 49.8. Well, what's this angle?
41.
Approximately
41.
40.2. Okay? Do you see how this would be to the north, up from east, or north of east?
Yeah.
And this would be to the right or to the east of what? North. This would be east of north.
Would it be like of 0 east or 0 north?
Could you just put enemy?
That is a good question. What if you
That's what I put.
drew him walking
Oh,
up
that's
on the
what you
other
put.
side?
Okay.
Then
Other side of stuff.
it doesn't matter. I mean, what you're walking up this line. So
What if he was walking up that line? Then
What
it
line?
would be the other side.
this side?
Yeah.
Well, that would be different. Then we'd have our x component here, and this would be west of north.
Or northwest.
And this
That'd be north of
would
west,
be
would be.
north of west.
But not northwest.
That'd be like saying this.
So.
This would be right to the west of north. This would be to the north of west.
Maybe let her answer.
If I'm going this way, yeah. If I'm going this way, it would be south of west.
Of west.
And this would be west of south.
Yeah.
If we're going this way, it'd be what? South of east and east of south.
So if you did it the other way, would it still be right? If you did
If you have, well, you can't, we're not, well, I guess if you wanted to go this way, but you typically want to keep it in the positive direction if you can. Yeah. Usually it's only one way to do it, but I guess how you're saying she could have walked up that way. Sure, you're right. She could have, but then we would have to worry about a whole, yeah, just keep it on the positive side if you can.
No negative.
Positive neuron.
Because this would probably be, yeah, this would be a negative, yeah. Okay?
Negative neuron is.
So what did I say? 49.8 degrees east of north? North of east.
Oh my word. That's not taking.
It'll take some time.
a
It
solid
will.
30 seconds on
It-
the test for each problem.
It will take some, you'll get good at it, I promise. That's usually not an issue. Right away, I hear this all the time from students, is exactly how you guys are responding right now. But after a few days, it's a non-issue in other classes, and I usually have not as intelligent classes.
We don't have original content.
You think we're
This
intelligent?
is probably, as a whole, the highest level I've had.
In your 6 years.
I mean, we'll see. It could be different, but the only class that I would say would be on your level would be like,
Aaron Bush.
yeah, your brothers, Aaron, Tim Drayback, Tim Early, Ben Taylor.
Are you just smarter than us?
Okay, but they also had a couple kids in that class who weren't quite as at that level. Okay, Reed never took physics.
I know.
I'm still better about that. All right, here we go. Next one.
Avery Langholm.
This one's a little bit different context here. A plane moves 599 meters northeast along runway. If the northern component of displacement is 89, how large is the eastern component?
I'll say so.
Plus they're giving us the angle.
A and C. Stephanie.
There he is.
What's the matter? What happened? Alright, here we go. So what did they give us? They gave us this vector, didn't they?
Yeah, they give us C.
And they also gave us what?
A. Or
Or B, whatever.
Or, yeah. One.
That's it. They just said northeast.
Oh, yeah, they said.
I don't say any north.
Everyone see what they gave us?
Oh
No.
my word.
Yes.
Why am I so lost? Along a runway. Why do you draw an
This
angle?
says more.
This says northeast.
What is that, north?
I could take the runway and pop it up.
Oh.
Okay? For example, right, when you're on a runway, as you're off the runway, you're probably at a northeast angle, right?
Yeah.
Yeah.
Right? So that's probably what they're saying, assuming here in this context. Okay? And it wants to know how large is the eastern component, or how large is the x component, I guess, in this context. Does that make sense? East, north?
Yeah. You can just move.
How do you know which angle you have to find?
You're always gonna find the angle that's like opposite the right angle.
Okay. Wait.
Okay, or the one that's on the origin typically.
So they gave us that hypotenuse in the line.
Okay? So let's first figure out how we're gonna find this component. Which I know this is gonna drive you nuts, but I don't care. Are we gonna say this is a squared or this?
X equals this space.
Okay, x is a squared, so it'd be c squared minus b squared equals a squared. Make sense?
And your answer is?
Is there something wrong? Oh, well. Okay. So then you just take the square root?
Yeah.
C squared is your 599?
Yeah. Can you?
Please.
For which one?
Not draw hydrophilic.
I got it.
Oh,
We'll see if it's.
yeah. Can you do it to 590 for 6 weeks, or does it need to stay in 590?
Yeah, it would be 590.
But
Dang it, I still have to get you guys caught up on sig figs. No, I should not. I should have just made you guys do it yourself.
well, I mean,
Me too,
I guess. I mean, there's a.
590 meters, but I still need a direction for this. What is it?
It's
North of east.
north of,
East.
Just straight east.
Okay.
It's the
what?
x component. It's the east component. This is straight east.
Oh, yeah.
No, if it's straight east, the angle's 0. If it's straight north, the angle's 0. If it's straight south, the angle's 0. If it's straight west, the angle's 0. Does that make sense?
Yes.
Okay? Then it wants the angle of the hypotenuse side.
Why?
Okay? Okay, so it wants this angle here.
Yeah.
Inverse tangent, right?
599 minus 89.
Hey, please stop me if you have questions.
Isn't it 592?
Yeah, sig figs is 590.
He drew this and then he made it one.
Okay? So what's my opposite?
Inverse
Opposite
89 over.
is 89
Opposite
over
over
50, 599.
Oh, it actually,
89
Yeah.
over.
599.
Looks like this angle is going to be really big or really small.
Really small. Real small.
Depends on which side you're referring to, right?
Okay.
Right?
Yeah.
It's really small if it's this angle, it's really big if it's that angle. Okay? What was the angle?
Is it
8.5.
or north?
8.5.
8.5 degrees. What of what here?
North of east.
North of east. What would be the other way you could say it?
Wait, why is it not? Why is it not 0.6?
0.6
Yeah.
degrees?
No, 8.6.
Oh, I don't know.
You could also say it.
Oh, you use this.
81.5.
My answer is from with 592.
Oh.
You could also
But-
say
Can you
81.5.
remind me why are you doing the tangent on
Because tangent of theta, I want to isolate theta, so I gotta take the inverse of tangent, which is tangent to the -1. Okay?
So do we have to like circle both of those?
In this case, yeah, because they're different context problems, so that would be one answer, and this would be the other answer. Now, you could take this minus 90 and do east of north if you wanted to. Okay? I do want to make sure I at least begin this one. Actually, I want to try to get through most of this.
Actually,
Context here. Okay, we got a southwest here, so now we're going this way.
It's
Negative 478 meters.
kilometers.
Kilometers.
Oh, hit.
Where's your beam?
Where's your beam?
So that makes that 478,000.
Yeah, negative 40.
If the top, what does that say? If the train is displaced south, so that would be
Along the
that.
origin?
What?
I'm thinking matter was
It could be here if you
Oh,
want.
okay, because
Yeah.
I drew mine along the origin.
Yeah, but then you'd have to have an X here, and I already had an X there, so. Does that make sense?
Yeah.
Why I did it that way?
Yes.
Negative 42 kilometers. So it first wants us to find your X, which is going to be what for a direction?
South, north, east, west.
South.
Which
Name all the
West.
directions from your X.
So here's what you would do. You would do your Pythagorean theorem. When you do it, okay, you have to, what is it, C minus c squared minus a squared like the previous one, since we're not doing hypotenuse here, you should get 476 meters west, or negative 476. But the reason why I put west is because negative 476 could mean two directions. Could be west, could be south. So it's always better to put the actual direction versus the sign. Okay? Now, what?
Can you put both, like you put the negative and the west?
That would be like putting two negatives.
That's what I was thinking.
Yeah, don't do that. Either the negative or the west. Okay, now the second part. Doesn't want to know direction. This would be inverse tangent again.
Why is the square root of negative number still coming out?
Okay? So what was our opposite? Negative 42. And what was our, negative 476?
I got 479.
As well.
Keep getting it.
I might have messed up. I wouldn't worry about it that much.
Okay.
Yeah.
That's it.
Okay.
I got 476.
And then what's the angle here? Approximately 5 degrees. Now, what's nice is we can, we don't have to worry about this angle, if that makes any sense. That's not the 5 degrees. That's from the west component there. So we would simply say 5.0 degrees, what of what?
South of west.
South of west. Downward from west. West, down. South of west.
I know that.
Why is this?
All right.
Kramer, why do we use tangent?
You could use the other one.
Usually using west.
But usually tangents, based on what you normally are given, you could use the other ones too, because based on normally what you are given, well, we eventually found the tangent side.
He's a 10 for that car ride.
Why don't we put it here?